Welcome to the first video of Module 4, Lesson 1. All of Module 4 is over exponential and log functions. But before we can get into exponential and log functions, we have to get into inverse functions. And before we can get into inverse functions, we have to start with composite functions. So your definition of a composite function here is given. Given two functions f and g, the composite function denoted by f of g, reads as f composed with g, is defined by this right here. So we a lot of times call this fog, right? But this isn't an O. This is a little dot with an open circle. And so this is f composed of g, but a lot of times we'll say right here, this is f of g, okay? Our function f of our function g. So suppose we have our two functions, f of x is 5x minus 1 and g of x is 3x squared. We need to find the following. So if we have f of g of 1, what this is f of g of 1. So we start with the inside and work our way out. So let's start with f of g, or sorry, g of 1. So I'm going to take my g and I'm going to replace my x with 1. So this is 3 times 1 squared, which is 3 times 1, which is 3. Okay, that is only my g of 1. So now I have f of g of 1. But what do we find g of 1 to be? We found it to be 3. Now I can do the process again by plugging in now a 3 everywhere I see an x. So this is 5 times 3 minus 1, which is 15 minus 1, which is 14. Now let's see what happens when I write this the other way. Instead of f of g of 1, now we have g of f of 1. So if I use my definition and write this out, this is g of f of 1. So start on the inside and work your way out. So let's find f of 1. So where I see my x here in my f function, I'm going to replace it with 1. So this is 5 times 1 minus 1. We get 5 minus 1, which is 4. Okay, again, that's only my f of 1. So now I have g of, my f of 1 equals 4. And now I'll take my g function and replace this x with a 4. So this is 3 times 4 squared. 4 squared is 16. 3 times 16 gives me 48. A lot of times we look at these and we say, well, they're just in opposite order, but they're still of 1, so they have to be the same thing. These are not the same thing. So just because we found f of g of 1 to be 14, you cannot assume that it's going to be 14 for the opposite order, and in fact, it rarely is. Now we have f of negative 2. So this is f of negative 2. Start on the inside, work your way out. So I'm going to take my function f, and I'm going to replace my x with negative 2. So this is 5 times negative 2 minus 1. Negative 10 minus 1, so this is negative 11. That is only f of negative 2. So now I need to do f of, well, my negative 2 was negative 11. And I'll do the same thing, but now I'm taking the same function and replacing it with negative 11 instead of up here we did negative 2. So 5 times negative 11 minus 1. We get negative 55 minus 1, so we get negative 56. And then our last example, g of -2. Start on the inside, work your way out. I'm going to take my g function and replace my x with -2. So we have 3 times -2 squared. -2 in parentheses squared is a +4. So this is 12. So now g of -2 was 12. Take the same function, and now instead of replacing x with -2, now we're doing 12. So this is 3 times 12 squared, which is 3 times 144, which is going to be 432. So this is how we do this whenever I'm given my two functions and I'm told what to put in for x. What happens if now I am given a table? And so to read this table, whatever your x is, you come over here. So if x is -3, -2, -1, 0, 1, 2, or 3. And then if we're dealing with our f of x function, we'll go down. But if we're dealing with our g of x function, we'll take whatever our x is and we'll look at what the g of x equals. So here we have fog of -2. So this is f of g of -2. So what is my g of -2? Well, we're going to go along our x right here to -2. And because it's g, we need to go down here to g. So this is 2. And then f of 2, now we'll go along our x right here to 2. And what is my f of x when x is 2? That's going to be 3. Here we have g of f of 1. So f of 1, start on the inside first. So when x is 1, what is my f? My f is 1. So this is g of 1. So now go along when your x is 1. Now I'm looking at my g function. It is 0. f of 2. When x is 2, my f of x is 3. So this is f of 3 now. And when x is 3, what is my f of x? It is 5. And then we have g of 0. So what is g of 0? Well, when x is 0, my g is -1. And now -1 is my x, and I'm still looking at g of x, so it bounces back to 0. Okay, so that's how you use a table. We don't have the function there. We just know what f of x equals and what g of x equals, depending on what my x is. Likewise, we can do the same thing if we are given the graph of our functions. So here we have f of g of 1. So here, what does g of 1 equal? And we will put that in here. Well, in my graph here, here's my g of x. Here's my f of x. Remember, this is x. So when x is 1, we'll come back up here and meet my g of x. My y is 6. And now f of 6, we'll go over here to 6. My g of x is above, so I'm not going to go above. I want to go down here below where my f of x is. And what does my y equal with that? -5. Here we have g of f of 1. So what does my f of x equals 1, or f of x of 1 equal. Okay, start inside, work your way out. So I go here to 1, and I'm on my f of x, right? That is my f of x graph. And so what is that y value with it? Well, it's 0. So now I'll go to 0. And I don't want to go here because that's my f of x. I want to go to g of 0. So when g is 0, what is my y? Well, that y is right there at 7. Again, f of g of 1 and g of f of 1 are not equal. Now we have f of 2. So what does f of 2 equal? Well, here's my 2. I'm going to go to my f of x graph. And what is my y? That's -1. And then we'll go here to -1. Here's my f of x. And what is the y with that? It is 2. Here we have g of 0. So what is g of 0? Well, here's 0. Here's my f of x. I don't want that. I want my g of x. So that is 7. And then g of 7, we'll go over here, 7 will come up here, and it also happens to be 7. Okay, so that's how you use composite functions when you are given a function, given a table, or given a graph, and you are given some value to plug in.